Welcome to the S4 Virtual Live Demo for the S4 Open BACnet-N2 Router Release 1.51. I'm Steve Jones, your presenter for this demonstration. Live demonstrations and hands-on exercises are a core part of our two-day S4 bootcamp. Bootcamps are customized to the attendees and have a technology focus, a sales focus, or are a combination depending on the attendee's goals. We ask each attendee to bring their global controller and BACnet operator workstation with them and have the JCI mTools utilities available for their hands-on workshops. This video attempts to capture the product demonstration segments of a S4 bootcamp. We will use a series of 3 modes during the demonstration. Introductory graphics to set the context, the S4 Open Management Console first to introduce you to the features and capabilities, and then to perform an actual integration, and YABE to demonstrate the success of the integration. This image represents a typical Generation 2 Metasys installation. The NCM was used for large buildings, the N30 was used for small buildings. The current generation of Metasys uses various models of the NAE or NIE for branch installed systems. These systems provide their user interface via an onboard web server. The Facility Explorer, a tritium derivative, is used by JCI ABCS franchisees. All generations of Metasys support legacy N2 field devices. During our demonstration, we will be using a NAE in the S4 test lab and a representative sample of N2 device. The S4 Open appliances are unique in that they implement a 3-way integration. Both the Metasys Supervisory Controller and multiple BACnet clients can be online at the same time. The S4 Open appliance acts as the gatekeeper to coordinate access to the N2 bus and devices. A major function of the N2 router is to throttle the Ethernet-based transactions down to the speed of the N2 bus. A transparent caching service improves performance and protects the N2 bus from aggressive BACnet clients. Because the N2 bus and field devices now have to support transactions coming from both BACnet IP and the Metasys Supervisor Controller, they will be pushed harder than they ever have been before. For this reason, it is critical that you validate the N2 bus is electrically in spec and that the N2 devices are working properly as part of the integration process. The S4 group has made significant investments in building a test environment. The lab includes over 90 N2 devices representative of all 3 N2 product families, N2 Open, VMA, and System 91. The lab includes various generations of Metasys supervisory controllers, global controllers, and BACnet operator workstations from many BAS manufacturers are included. We have also invested in numerous BACnet test tools to validate that our products conform to the BACnet standard. We understand that it is not practical for many of our integration partners to support a test demo environment this extensive. So, we frequently host remote interoperability test sessions with our partner. This slide shows the S4 Open BACnet-N2 router inserted into a Generation 2 Metasys installation. Throughout this demonstration, we will use the terminology upstream N2 interface and downstream N2 interface. This refers to N2 communications relative to the N2 router. Upstream faces the Metasys Supervisory Controller. Downstream faces the N2 bus and devices. The N2 bus has been unplugged from the NCM N30 and moved to the downstream N2 interface of the N2 router. An upstream cable has been plugged into the upstream N2 interface of the N2 router and connected to the N2 port of the NCM or N30. The Ethernet interface provides connectivity for the BACnet IP transactions and communication with our S4 Open Management Console. We will now move to the S4 Open Management Console and provide an overview of the S4 Open BACnet N2 Router feature. This is the S4 Open Management Console. It is a separate program included with your purchase that you load onto any current generation Windows PC. The Management Console provides the user interface for all S4 Open BACnet N2 routers in your facility. It is based on the Microsoft Management Console technology and provides a user experience very similar to the Windows File Explorer. That is, a left side navigation pane and a right side details pane that is responsive to your selection in the navigation pane. When initially installed, only the S4 Open Management Console node will be displayed in the navigation pane. Each installed N2 router announces itself to its local IP subnet every 30 to 45 seconds, depending on system workload. The Management Console listens for these announcements and automatically creates a node in the navigation pane for each N2 router. If the N2 router is in another subnet, you can manually create a link to it, right-click the Management Console node, select New Link to S4 box. The General tab provides identifying information that the installer can customize. This information is published to BACnet. It also provides version identification and licensing details. You can remotely reboot the system using the link on this window. However, we do not take the time to demonstrate that capacity during this video. The Configuration Properties page provides a summary of the current system configuration. We will be working with 6 N2 devices for this demonstration. They are representative of each family of N2 device. We have kept them at lower N2 addresses to quickly demonstrate the capabilities of the N2 router without having to wait for the entire bus to be examined. This tab provides a high-level indication of system performance. CPU load and memory load are self-explanatory. Communication system load is an indication of the length of both BACnet and N2 transaction queues. If this statistics is in the single digits, the system is performing perfectly. It is processing all BACnet or N2 transactions submitted to it. You will see other performance statistics throughout this demonstration. One of the things that differentiates the S4 Open appliances is the instrumentation that we built into the system to monitor performance and assist in troubleshooting the N2 bus. The device template catalog is one of the most powerful concepts in the S4 appliances. They provide the point mapping and BACnet properties for each N2 device. Templates are provided for each N2 hardware and loaded application that acts as an application-specific controller. Templates are also provided for vendor devices, Metasys integrators, and Centaurus integrators. The system is delivered with the most common templates preloaded. Our support USB stick contains the complete catalog that can be imported as needed. S4 provides a separate utility to parse the .dmo configuration file for a DX9100 device and create a custom template for it. Templates can be pruned or edited to meet your engineering standards or the needs of a specific project. The BACnet tab provides properties for the N2 router itself. The S4 Open BACnet N2 router acts as a BACnet router and therefore has its own identity as a BACnet device. It typically is assigned to whatever BACnet network is designated as your BACnet backbone network. Since it is a BACnet device, it must be assigned a unique BACnet device ID within your BACnet enterprise. BACnet BBMD services and foreign device registration can be configured as needed for each installation. The N2 router node expands to expose two subordinate nodes. We will first examine the network connections node. Network connections contains the physical world that the N2 router resides in. This includes the upstream N2 interface if licensed, one or more downstream N2 interfaces, and definition of the BACnet IP protocol running under the Ethernet connection. At first look, you might think I'm confused, talking about BACnet properties for an upstream N2 interface. Because we wrote our own BACnet stack, we had a lot of flexibility to do whatever was necessary to provide the upstream N2 integration. This interface is a system option and is utilized for large, complex projects, for critical environments, or when the N2 router is being utilized as an agent for value-added applications. With both the Metasys supervisor controller and one or more BACnet clients all trying to control points on N2 devices, we needed to provide a deterministic way to mediate who has control. The supervisor controller as a BACnet client forces N2 transactions coming from the Metasys supervisor controller to participate in the BACnet priority array mechanism, even though they are not BACnet transactions. You turn on the option and select the priority for the N2 transactions with the drop-down menu. N2 transactions then follow the rules of the BACnet priority array mechanism. Thus, you have a way of migrating away from Metasys control of field devices on a point-by-point basis simply by having your BACnet client operate at a higher priority level. The N2 transactions will be parked, and the BACnet transactions will be applied to the N2 field device. Performance statistics are provided for each physical interface. Most of these are standard data communication statistics. A few are unique to the Metasys N2 environment and will give you an indication of any mismatches between the configuration in the Metasys supervisor controller and the devices actually found on the N2 bus. These statistics are different in a couple of ways. Since this is the downstream N2 interface, the exact statistics are different from the upstream interface. But again, they are mostly standard data communication measurements that reflect the performance of the N2 bus. The graphic separates the load being generated by the legacy Metasys supervisor controller versus load originating on the BACnet interface. COS, or change of state, is a Metasys N2 service that is similar to BACnet change of value services. Of particular concern is timeout errors. The N2 protocol does not have transaction numbers, sequence numbers, or any other mechanism to tie responses to requests. Therefore, everything must be coordinated by very careful timing. Processing of timeout errors blocks the N2 bus for the duration of the event and can impact access to all devices on the bus. The TCP/IP tab provides the ability to configure the TCP/IP address for the N2 router. It can either be automatically assigned or statically assigned. Next, we move to the BACnet Properties tab of the Ethernet interface. This is where you select configurable properties for the BACnet protocol. You have the option of disabling more sophisticated BACnet services if required for special conditions. If you choose to do this, these services will be advertised as not supported to the BACnet client, which will then fall back to a more basic and probably more verbose method of communicating. An example of setting these options is for Tritium or Niagara BACnet clients. A best practice is to disable read property multiple and write property multiple services. The BACnet Performance tab provides an indication of how well the client and S4 Open BACnet-N2 router are communicating. Now we move to the building control network. This is where all the discovered N2 devices are virtualized and published as BACnet IP devices. On the Building Control Network Properties tab, you specify the BACnet virtual network number for the N2 router. This must be a unique network number within your BACnet enterprise. Each legacy N2 device is published as an emulated BACnet IP device under this BACnet network. Full bidirectional support is provided for all N2 points, and to read, write, override, and release operations are supported through BACnet. Now we're going to drill down into a specific device and look at its properties. The General tab shows the status of the N2 device, its native N2 address assignment, and the S4 template assigned to that device. You can drill down into the type link to manually assign a S4 device template of your choice to the device. The Physical Device tab links the emulated BACnet device in the building control network to the downstream interface and legacy N2 device in the physical world. The BACnet tab identifies the BACnet network number and device instance number assigned to the emulated BACnet device. The Configure wizard assigns a unique BACnet device ID to each emulated device based on the N2 address of the legacy device. This selection can be overridden by the integrator as long as the BACnet standard is followed. As we make this transition to point level details, I would like to mention that clicking on any column heading in the detail pane will sort the listed objects by that property. We're going to look at room temperature as our example point. On the General tab of the Properties page, you can adjust the data type and read-write permissions, set the on-off text, engineering units, and multi-state enumerations, and modify the description of the point that is published to BACnet. The Data Source tab provides a methodology to determine if a N2 command is sent as a N2 override, N2 release, or N2 write. Test reads and writes commands can be issued. On the BACnet tab, you can specify the published BACnet object type and instance number, specify the name of the point as you want it published to BACnet, And for special conditions, you can have the operation of publishing a point without the BACnet priority array. This completes the introduction to the N2 Router user interface. We will next prepare for performing an actual integration. I will select all the objects in the building control network and delete them. Followed by the same process for the downstream network. This takes the system configuration back to close to what it would look like when you first take it out of the box. To prepare for running the configure wizard, first confirm the TCP/IP assignments for the router. Okay, confirm the BACnet assignments for the N2 router itself. Assign the virtual BACnet network address under which all emulated BACnet IP devices will be published. What you will experience is the configure wizard automating the integration process. Most gateway products make this a manual, labor-intensive, and therefore error-prone process. I'm going to move the wizard window to the right so that you can see what is happening in the building control network as it is running. The configure wizard will walk through the N2 address space on each downstream interface. When a device is encountered, it can identify the hardware type and loaded application. Note the progress counter. As I mentioned before, we have 6 devices, so this will go pretty quickly. With this information, it will assign a device template for each application-specific controller and prepare it for publishing to BACnet. This is a vendor device, so I'm going to skip to the next device, and you'll see why in a minute. Now that we've found all 6 devices, I'm going to take a shortcut here and not look at the rest of the addresses on this bus because I know there are no other devices. And I simply move the process forward with the next button. What I'm doing now is entering a parameter that will be added to the N2 address of each N2 device in order to create a unique device ID for each emulated BACnet device. And now you see the devices have all been created, both in the wizard and in the building control network. Okay. Most of these devices have their point lists already assigned. Okay. The exception is the TCS Basis vendor device, and in order to assign the point list there, I go to its properties page, drill down into the device type, and select the TCS Basis template. Apply it, and as you can see, we now have a user-friendly list of points. The integration is complete, and the system is ready to support publishing to your BACnet client of choice. This may be a new BACnet operator workstation, a building level controller, or one of many available value-added applications. As a verification, we will launch YABE, yet another BACnet Explorer, and have it discover all devices on BACnet default port 47808. This represents an important step in the integration process, verification that you are receiving the expected data through BACnet. Next, we will ask it to provide details for the N2 router itself and each of the 6 emulated BACnet IP devices representing the legacy N2 devices that we just integrated. And that's as simple as just touching each device and its properties will get expanded. Okay, we're going to choose the TCS Basis vendor device again as our target since we've been working with it. And again, I have to touch each of the points to see its properties expand. And this will go very quickly. And in fact, I'm going to stop at room temperature since that's the point that I want to look at. And we're going to drag it into the monitoring pane. And as you can see, we have a valid value in the present value for the room temperature. This completes our live demo. Thank you for your time and attention. Many of you have heard me say over the years, we are not successful until you are successful. Do not hesitate to contact us if you have questions about the S4 Open BACnet-N2 router or would like to discuss a specific project that we might work together on to create another success story.